The Earth's atmosphere is a marvel of natural engineering. It acts as a shield that protects all life forms from the harshness of space. Without it, our planet would be a barren wasteland, unable to support the diverse ecosystems we see today. The atmosphere regulates climate, filters sunlight, and retains the heat necessary for life. This thin veil of gases is more than just air we breathe. It plays pivotal roles in weather patterns, protecting us from harmful solar radiation and keeping our planet warm enough to sustain life. Despite its resilience, it is not invincible. Human activities such as industrial pollution and deforestation are posing significant threats to this delicate balance. Understanding this evolution can inspire us to become better stewards of our planet. By learning how the atmosphere came to be, we can better appreciate its fragility and the importance of its protection. It is the very breath of life, encompassing the air that fills our lungs and the winds that carry seeds across continents. Its protection is essential for future generations, and our responsibility is to ensure that it remains a vibrant, life-giving force. When Earth first formed about 4.5 billion years ago, it was a hostile environment. The young planet was a molten mass, bombarded by meteors and devoid of life. The initial atmosphere was composed mainly of hydrogen and helium, gases left over from the solar nebula. This early atmosphere was thin and quickly stripped away by solar winds due to the lack of a magnetic field. The planet's surface eventually cooled, forming a solid crust. During this time, volcanic activity was rampant, releasing gases trapped within the Earth. The intense heat and pressure from these eruptions contributed to the transformation of the atmosphere. However, this early atmosphere still lacked the oxygen necessary to support life as we know it today. As the planet continued to cool, water vapor began to condense, forming the first oceans. These bodies of water played a critical role in absorbing carbon dioxide from the atmosphere. The initial atmosphere's disappearance marked a turning point in Earth's history. It paved the way for the development of a more stable and life-supporting environment. The intense volcanic activity on early Earth was a double-edged sword. It was destructive, yet it laid the groundwork for the second atmosphere. As volcanoes erupted, they spewed vast amounts of gases such as carbon dioxide, water vapor, and methane into the air. These gases were crucial in creating a thicker, more stable atmosphere. Unlike the initial hydrogen-helium mix, this new atmosphere was dense and capable of holding heat. The composition of the second atmosphere was vastly different from what we breathe today. It was rich in greenhouse gases, which helped trap heat and warm the planet. The presence of water was a game-changer, setting the stage for the earliest forms of life to emerge. The oceans acted as carbon sinks, absorbing vast amounts of carbon dioxide and moderating the climate. Despite these changes, the atmosphere was still devoid of oxygen. Methane and ammonia were prevalent, and the skies were likely a hazy orange due to the high concentration of volcanic gases. The second atmosphere provided a crucial stepping stone, setting the foundation for the dramatic changes that would follow. As the Earth continued to evolve, so did its atmosphere, driven by both internal and external forces. The Great Oxygenation event was a pivotal moment in Earth's history. Approximately 2.4 billion years ago, a new player emerged on the scene: Cyanobacteria. These microscopic organisms performed photosynthesis, converting sunlight into energy and releasing oxygen as a byproduct. This was the first time oxygen began to accumulate in the atmosphere, altering it forever. Initially, the oxygen produced by cyanobacteria reacted with iron in the oceans, leading to the formation of banded iron formations. This process kept atmospheric oxygen levels low. However, as these sinks became saturated, oxygen began to escape into the atmosphere. This marked the beginning of a dramatic transformation. The presence of oxygen had profound implications, paving the way for the evolution of more complex life forms. The buildup of oxygen in the atmosphere led to the formation of the ozone layer, which provided protection from harmful ultraviolet radiation. This allowed life to begin colonizing land, marking a significant step in the diversification of life on Earth. The Great Oxygenation event was a double-edged sword. It was a catalyst for biological innovation, yet it also led to significant ecological upheavals. Section 5. The modern atmosphere, layered and complex. The Earth's atmosphere has continued to evolve, reaching its current state with distinct layers. Today, it is composed of 5 main layers, each with unique characteristics. The troposphere is the lowest layer where weather occurs and life thrives. Above it lies the stratosphere, home to the protective ozone layer. The mesosphere, thermosphere, and exosphere follow, gradually transitioning into the vacuum of space. Each layer of the atmosphere plays a crucial role in maintaining Earth's climate and supporting life. The troposphere contains the air we breathe and regulates temperature through the greenhouse effect. The stratosphere, with its ozone layer, protects life from the sun's harmful ultraviolet rays. Beyond that, the mesosphere is where meteors burn up upon entering the atmosphere, while the thermosphere hosts the auroras. The exosphere marks the boundary between Earth's atmosphere and outer space. The modern atmosphere is a complex system, shaped by both natural processes and human activities. Understanding the structure and dynamics of the modern atmosphere is crucial for addressing environmental challenges. Section 6. Human impact. The atmosphere under siege. In recent centuries, human activities have increasingly impacted Earth's atmosphere. The burning of fossil fuels, deforestation, and industrial processes have released large amounts of greenhouse gases, such as carbon dioxide and methane. This has led to a phenomenon known as global warming, where the planet's average temperature rises due to the enhanced greenhouse effect. Air pollution is another significant issue, affecting both the environment and human health. Emissions from vehicles, factories, and agriculture introduce harmful pollutants into the atmosphere. These can lead to respiratory diseases, environmental degradation, and the formation of acid rain. The depletion of the ozone layer is also a concern, primarily due to the release of chlorofluorocarbons, or CFCs, from industrial products. The impact of human activity on the atmosphere is evident in the increasing frequency and intensity of extreme weather events. Hurricanes, droughts, and heat waves are becoming more common, with devastating effects on communities worldwide. These changes underscore the urgency of addressing climate change and reducing our carbon footprint. Section 7. Fun facts, mysteries of the sky. The Earth's atmosphere is full of wonders and surprises. Did you know that it extends far beyond what we can see? The exosphere is the outermost layer, reaching up to 10,000 kilometers above the Earth's surface. Although it is incredibly thin, it marks the transition between our planet and outer space. This layer is where many satellites orbit, providing crucial services for communication and navigation. Auroras, also known as the northern and southern lights, are one of the most stunning natural phenomena associated with the atmosphere. They occur when charged particles from the sun collide with gases in the thermosphere. These collisions produce brilliant displays of light, painting the sky with vibrant colors. Auroras are best observed near the poles, where the magnetic field lines converge. The atmosphere is also home to a variety of unique weather phenomena. For instance, noctilucent clouds, which are the highest clouds in the atmosphere, form in the mesosphere. They are only visible during twilight, glowing with a bright bluish hue. Section 8. Resilience and protection. A call to action. The Earth's atmosphere is remarkably resilient, having withstood drastic changes over billions of years. However, its ability to recover from human-induced stressors is limited. Protecting this vital resource is essential for the health of the planet and future generations. Efforts to reduce emissions and conserve natural resources can help mitigate the impact of climate change and preserve the atmosphere's integrity. Education and awareness are crucial in fostering a culture of environmental stewardship. By understanding the importance of the atmosphere and the threats it faces, individuals can make informed decisions about their impact on the environment. Schools, communities, and governments play a significant role in promoting sustainable practices and policies. Innovation and technology also offer solutions for protecting the atmosphere. Advances in renewable energy, such as solar and wind power, provide alternatives to fossil fuels. Carbon capture and storage technologies can reduce emissions from industrial processes. Ultimately, the protection of Earth's atmosphere is a shared responsibility. Section 9. Sharing knowledge, preserving our future. Sharing knowledge about the atmosphere and its importance is key to inspiring action. By educating others, we can raise awareness of the challenges facing our planet and the steps needed to address them. Social media, community events, and educational programs are powerful tools for spreading information and encouraging participation. Everyone can contribute to preserving the atmosphere. Simple actions such as reducing energy consumption, recycling, and supporting sustainable practices can make a difference. By making environmentally conscious choices, individuals can reduce their carbon footprint and help protect the atmosphere. Encouraging others to do the same amplifies the impact. Engaging with policymakers and supporting initiatives that prioritize environmental protection is also crucial. Advocacy for policies that promote clean energy and protect natural habitats can drive systemic change. Participation in local and global environmental movements can amplify voices and influence decision-makers to act in the best interest of the planet.